Welcome to question 6 of the Year 12 end of unit test for amount of substance. A solution of potassium hydroxide of unknown concentration is titrated against hydrochloric acid of concentration 0.85 moles per dm cubed. And here is our equation. And we can see immediately it's 1 to 1 to 1 to 1. Excuse me. Samples of potassium hydroxide solution of 25 cm cubed required an average titra of 21.3 cm cubed of hydrochloric acid for complete neutralisation. So I needed 21.3 cm cubed of this hydrochloric acid to neutralise samples of 25 cm cubed. So what's my strategy? My strategy is work out the moles of HCl, which will then give me the moles of KOH. That moles of KOH will be in 25, and then I'm going to factor up to give me how many moles there are in a litre of dm cubed, and that will be my concentration. Calculate the concentration of this potassium hydroxide solution. Now I can do this, this is an incredibly generous 4 marks, I can do this all in one calculation, can't I? So my moles of HCl will be my volume of HCl, 21.30 divided by 1000, because that's in cm cubed and I need it in dm cubed, so that's my conversion into dm cubed. Then I'm going to times that by my concentration, because we remember that moles over vols is conc. Here's my vols. Vols times conc give moles. So my conc for the acid is 0.85, which is in suspiciously 2 significant figures. So that is my number. That is my number of moles for hydrochloric acid. Now, because it's a 1-to-1 reacting ratio, I'm going to times by the one I want and divide by the one I have, times 1 over 1, only joking of course, that's just timesing by 1, don't need to do that. But if it was a 2-to-1 reacting ratio or a 1-to-2 reacting ratio, we would have had to make an adjustment there. So this sum here is equal to the moles of KOH in 25 cm cubed. Well, if I've got that number of moles in 25 cm cubed, I just need to factor up to find out how many moles are going to be in a litre. And the way I'm going to do that is I'm going to times by 1000 over 25. 1000 over 25 is 40. So, yeah, I think I should be able to do that all in one go. Oh, mind you, on this antiquated calculator from Pound Stretcher, we're not so sure. 21.3 divided by 1000 equals times 0.85 times 1000 equals divided 25 equals 0.7242. Now, when you've done a titration calculation, just have a quick sense check of it. Now you know that 25 cm cubed is neutralising roughly the same volume of acid, and you know that it's roughly a 1-to-1 reacting ratio. So you should be expecting a concentration to be roughly the same. Your acid was 0.85 and we've just worked out a concentration of 0.72. 0.72, 0.85, they're very, very similar, aren't they? And because it was less hydrochloric acid, you would expect the concentration to be more, because there was more KOH needed than acid, you expect the concentration of the KOH to be less, which it is. So our sense check, this answer here passes our sense check to be of being a roughly equal concentration. We're not going to leave it in 4 significant figures. We're going to look for our lowest amount of significant figures, which was 0.85 moles per dm cubed, so equals 0.72 moles per dm cubed. 4 marks. Happy days. Computer's turned off. Bear with me while I log back in so I can turn it off.